All right, welcome back. This is the beginning of Chapter 6, Definite Integrals. And we're going to start with estimating with finite sums. And what I want to talk about is the idea of accumulation as an area. So when we're talking about this, most basic example, let's talk about a ship sailing at sea. It is going 7.5 nautical miles per hour. So this is the velocity in nautical miles per hour. And it travels this distance from 7 to 9. This is time in hours. Now, if I look at this problem, clearly I know that the distance that the ship traveled is 7.5 nautical miles per hour times 2 hours, which is 15 nautical miles. Well, another way to think of this, when I realized that looking at this graph of what's going on here, is that the distance traveled by the ship is also the area under the curve between 7 and 9. So we're going to explore this a little bit further. The idea that we can add up, we can calculate something, an accumulation, by looking at the area under a curve. Now, where do we run into problems? Because that was pretty easy. Why do we need area under a curve? Well, what if instead of traveling at a constant speed, the ship travels at a variable speed? So what we now see is that in this interval from A to B, we can't just multiply height by base because we don't know the height. It changes. But what we can do is we can split this up into tiny little rectangles. Now, if we recognize that this rectangle here is the distance traveled during this time interval, so we have a time interval, and this area represents the distance traveled in this time interval, well, we could then say, well, what if we just added up all the little rectangles? The sum of the rectangles would be the total distance traveled over the interval AB. So we can now accurately do this. So let's look at a sample problem. Our sample problem is that it starts snowing, and it starts snowing at 3 a.m. And from 3 to 5, it increases the rate of snowfall from 0 to 1.2 inches per hour. And from 5 to 8, we have a constant rate of 1.2 inches per hour. And from 8 till 10:30, the snowfall decreases from 1.2 to 0 inches per hour. And we'll assume that the increase and the decrease are at a constant rate, which makes them a linear problem. So if I graph this, here's what I see. Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And there's not 3. Really? Stop. Sorry. There's 3, 5, 8, and there's 10 and 11. And here's 1.2 inches per hour. So starts at 0 here, ends at 5 o'clock there, and then is constant until 8 o'clock right there, and then decreases in a linear fashion until 10:30 right there. How much snow fell? Well, this is the rate of snowfall in inches per hour. This is the time in hours. We can split this up into 3 sections. We'll call this section 1, section 2, and section 3. Section 1, well, we have a triangle. Base times height divided by 2 is 2 times 1.2 divided by 2. Section 2 is a rectangle. We have 3 hours at 1.2 inches per hour. And section 3 is a triangle with a base of 2.5, a height of 1.2 divided by 2. And when we add these all up, we get 6.3 inches of snow. All right, basic introduction there. I'm going to stop this, trying to keep these videos under 5 or 6 minutes at a time, and I'll come back in video 2 with a couple more examples.